Okay, welcome to your KIN 425 lecture for February 24th. First thing I'm going to do today is I'm going to go over the answers to those questions that I gave you during the WebEx session that we had on Monday. So I had 3 questions remaining from this handout that I gave on oxygen consumption problems. So in this second question, it's Sasha is doing aerobic exercise one day, and then she's doing resistance training the next day, and you can see that she has a certain heart rate and systolic blood pressure during each of those exercise sessions. And the question here is, which exercise places a greater stress on the heart? And that's question number 2. Question number 3, I've given you some variables on ventilation and fraction of expired oxygen and carbon dioxide, and I wanted you to determine the person's relative VO2. And then in the last question, you can see I've given you a whole bunch of variables, and I want you to determine the person's heart rate. So what I've done is I've got all these answers up on my whiteboard here. So I'm going to walk over to the whiteboard and go over each of these answers with you. So that first question asked about stress on the heart. And to determine the answer here, you have to determine what's called the rate pressure product, which is your systolic blood pressure multiplied by your heart rate. So you can see in the aerobic exercise session that Sasha did, her systolic blood pressure was 150 millimeters of mercury. Her heart rate was 140. So you multiply those two together, you get a number of 21,000. When she did the leg press session, she had a systolic blood pressure of 200 millimeters of mercury and a heart rate of 100 beats per minute. So you multiply those two together and it comes out to 20,000. So from this you can conclude that the aerobic exercise places a greater stress on the heart than that leg press exercise session. So that's the answer for number 2. For number 3, I've given you these variables. So body mass of 50 kilograms, a ventilation of 35 liters per minute, a fraction of expired oxygen of 17% or 0.17, and a fraction of carbon dioxide of 3% or 0.03. So these are measurements that you can measure with the metabolic cart in the lab. So the metabolic cart in the lab measures expired air. So from that expired air, you can measure your ventilation and you can measure the fraction of the concentrate or the fraction of gases in that expired air. So in this example, the expired air measured by the metabolic cart is 35 liters per minute. Fraction of expired O2 is 17%, and fraction of expired carbon dioxide is 3%. The remaining of that amount of air that's expired will be nitrogen. So that's something to keep in mind. So the question asks to determine the person's relative VO2. So you need to use this equation to figure out the answer. It's VO2 equals ventilation inspired multiplied by the fraction of inspired oxygen minus the ventilation expired times the fraction of expired oxygen. So this side of the equation gives you your volume of oxygen that you've taken in, that you've inspired, and this side of the equation gives you the volume of oxygen that you've expired. The difference between the two is the amount that you've consumed in your body, and that's what VO2 refers to, is your oxygen consumption. So from this whole equation, the only thing that we have to solve for here is your ventilation inspired. Your fraction of inspired oxygen is always 21%. So on Earth, the percentage of oxygen in the air that we breathe is always 21%. In the question, I've given you the ventilation expired, which is 35 liters per minute, And I've also given you the fraction of expired oxygen as measured by the metabolic cart as 17%. So we have this side of the equation solved. The only thing we have to solve to get VO2 is that ventilation inspired. So to solve for the ventilation inspired, you have to consider that the volume of nitrogen that you inspire is equal to the volume of nitrogen that you expire. And that's how you can solve for ventilation inspired. So you have to use this equation, ventilation inspired multiplied by fraction of inspired nitrogen equals to your ventilation expired multiplied by your fraction of expired nitrogen. In other words, this side of the equation represents the volume of nitrogen that you've inspired, and this side of the equation represents the volume of nitrogen that you've expired. And from this equation, you can solve for VI and then plug it into this VO2 equation. So the volume of nitrogen that you inspire is always equal to the volume of nitrogen you expire, because when we inspire nitrogen from the air, it does not react with the tissues in your body, and the volume of nitrogen that you inspire is always equal to the volume of nitrogen that you expire. So it's not like carbon dioxide or oxygen that are going to change. Your body consumes oxygen and it expires carbon dioxide. With regards to nitrogen in the air, the volume that you breathe in is equal to the volume you breathe out. So you can use this this fact to solve for ventilation inspired in this equation. So your fraction of inspired nitrogen is always 79%. So the fraction of nitrogen in the air that we breathe is always 79%. So we go down here. I've rearranged the equation because we want to solve for ventilation inspired, so we can plug it into this VO2 equation. So down here, I've got ventilation expired, which we've measured with metabolic cart. I've got the fraction of expired nitrogen, which is going to equal 80%. And the way I figured that out is I went back up to this fraction of expired oxygen, expired carbon dioxide. If you add those up, 17% plus 3% is 20%. The remainder is going to be nitrogen, which is 80%. So I've just taken 100%, subtracted 17%, and then subtracted 3% to get 80%. And as a fraction, it's just 0.80. The fraction of inspired nitrogen is always 79%. So the air we breathe is always 79%. So from that equation, you can figure out your ventilation inspired is equal to 35 times 0.8 divided by 0.79. You get 35.44. So now you're going to take that number and you're going to plug it into this equation to solve for VO2. So that's what I've done down here. VO2 equals your ventilation inspired multiplied by 21%, the fraction of oxygen in your inspired air, minus 35, which is your ventilation expired, which is measured by the metabolic cart, and that's given in the question, times 0.17, that was your fraction of expired oxygen as measured by the metabolic cart. So you end up with your VO2 is going to be equal to 1.49 liters per minute. Because I'm asking for relative VO2, you convert that to milliliters. You divide it by the person's body weight to get their relative VO2 as 29.8 milliliters per kilogram minute. And that's the answer for your question. If this was a VO2 max test and this was a young person, and I asked you whether this person was trained or untrained, your answer should be untrained. So this is a relatively low VO2 max for an untrained male or female.